Hello everyone and welcome to this section. I'm really excited to discuss the convolutions with you. Convolutions in image processing, it's actually one of the most powerful techniques that we're going to use for feature extraction and for actually manipulating our image. We actually do that and we use convolutions frequently in our daily applications by applying, for example, our Snapchat filters. That's pretty much performed through convolutions, okay? So let's take a look at what do you mean by convolutions, the mathematics a little bit behind it, and actually going to use a couple of practical examples. In the next section, we're going to see how can we apply these convolutions to sharpen an image, to blur an image, to do wonders with it, okay? All right, so what do you mean by convolutions? Convolutions is simply a kernel matrix, okay? So it's simply, we have our image, and what we're going to do is that we're going to get kind of a matrix that have a bunch of numbers, and we know an image is simply numbers too. So our image is a bunch of numbers in a very simple format, in a grayscale. It's again numbers that range from 0 to 255. And we're gonna get kind of a matrix. We'll call this matrix a kernel or a feature detector. And that matrix, we're just gonna go and scan our entire image, okay? Does something to it, okay? It generates a newer image. The image might be like, scaled down, might be grayscale, might be blurred, might be sharpened, might be whatever, depending on the actual values of the matrix that we applied on. That's in a very simple form, very in a nutshell. Okay? So convolutions use a kernel matrix to scan a given image. So that's my given image, and I wanted to scan on it to give me a certain effect, whatever effect I want. An image kernel is a matrix used to apply effects such as blurring and sharpening. We can do whatever with them, okay? We actually use the kernels, or we use the convolutions in general to, in a kind of an advanced neural network application. It's called convolutional neural networks. Actually, we're gonna cover it later on, to extract features from the image. So we're gonna use these kernels to give me different features from this image, okay? Which is kind of the most important pixels within the image, okay? All right, so let's take a look. So what we're gonna do here is we're gonna apply kind of kernels or feature detectors on this image that simply, which is this, when I say kernel, that means just a matrix, all right? That will simply extract or obtain from me, they will call it feature maps, okay? Which is, again, if you think about it in a very simple form, these are kind of, like an image as well, which is the same image as we have, but it like modified. There is a certain effect that has been applied to it, okay? So let's take a look at a practical example. I know it might seem a little bit different, a little bit weird to you, but let's take a look at a practical example. Let's assume that this is my image, okay? And my image has a bunch of zeros and ones, all right? And that's my actual grayscale image of, let's say, the autonomous car. And what we're gonna do here is that we're gonna use our feature detector, okay, or our kernel, okay, to actually go there and scan our matrix. So let's get started. So let's assume that we're gonna put this matrix on our image on the top left corner, as you guys can see here. Okay, so what do you guys expect? What we're gonna do is that simply we're gonna multiply the values of the pixel 1 times 0, and then 0 times 1, and then 0 times 0, which is simply multiplying the values of the matrix with the values of the actual values within the pixel of the image in a very simple form, okay? And that will simply sum them up. That will generate 1, okay? Simply that 1 came from here, okay? So if you have, all of them are zeros, right? So all 0 multiplied by whatever, we generate 0. However, this is the only value that has 1 and 1, right? So 1 times 1, that's the only one that came here, okay? Okay, what are we gonna do next? What do you guys expect? So what we're gonna do is gonna scan our kernel to move to the right, okay? Do the same thing, will generate 1. Scan a little bit more, that will give me 1. And we're gonna move to the next row. Obviously, we can go to the edges. There's a lot of, like we're not gonna get there. We're just gonna make it a little bit simple. We're just introducing the concept. And then what we're gonna do here, actually we got a little bit more value. We get 3, right? Why? Because we have 1 and 1, right? We have 1 and 1 again. And here we have 1 and 1. So that's why you have like lots of ones. That's why we got 3, right? And that's a kind of, more kind of distinct feature, okay? And again, we're gonna discuss that topic a little bit more when we discover feature maps moving forward. But that's again, how can we obtain convolutions, okay? I'm sorry. So pretty much if you take this and you could go through the entire image, that's what I'm gonna get through there. That's basically what we call it feature map, or what we call it the updated or new image in a very simple form, okay? All right, that's pretty much all what I want you to know when it comes to convolutions. So let's take a look at a couple of very well-known kernels, which is, one of them is what we call the sharpening kernel. The sharpening kernel, in a very simple form, it kind of emphasizes on some pixels and just ignores the others in a way, okay? So what we do, we want to sharpen the image. We want to make some of the colors pop, right? And we want to suppress the others in a very simple form, okay? And that's why you will see that's kind of, this kernel, which is these kernels. Again, it's very difficult to understand, but just in a way, you actually use multiply the center pixel by 9 in a way, and the other values are set into zeros or -1s or whatever, okay? And that's how you can actually sharpen an image, by simply enhancing the contrast of one pixel, okay? And we're actually going to discuss that in a lot more details when we apply it in an actual real-world application, okay? What about blurring? Blurring in simple form, we just want to average, average the image. So if you're just going to go and apply a matrix that has all ones, for example, okay? Simply, we're just going to multiply the entire pixel, the entire image by ones, and then sum them up and divide by the value. That will simply obtain kind of a blurred image. That would give me kind of, like an averaging of each pixels with its neighbors in a nutshell, okay? The key element here when we do the blurring, I'm going to show you as well in the actual notebook when we discuss it, is that we wanted to ensure that our normalization, okay, or the summation of our kernel has to be 1. If you don't perform the normalization, okay, you would see that the image we're going to become way brighter or way darker. We're just going to change the entire color of the image, okay? And I'm actually going to show you it's pretty interesting, okay? All right. That's kind of list of kernels that you guys can use, kind of a Wikipedia page. So that's a sharpening kernel, that's a box blur kernel. You can do Gaussian blur, you can do 3x3, you can do 5x5. You can do so many different kernels. There is endless, number of filters that you can apply, which is pretty much as filters that you guys can use, with like Instagram or Snapchat or whatever. All right, and that's pretty much all what I have for convolutions. I hope you guys enjoyed it. And in the next section, we're actually going to dig a little bit deeper into the Jupyter notebook and try to apply different kernels per se. All right, hope you guys enjoyed it, and see you in the next section.